So I'm actually feeling like I'm kind of in a bad situation, giving a talk straight after Manfred. So I'm in a big trouble. Wish me luck. So I'm honestly super excited to be here for the third time in a row in the third edition of NGDE. And today I'm going to talk about signals in general, but it's not yet another signal talk, okay? Actually, what we're going to do here is not just talk about signals, we're going to create signal from scratch altogether. So for any of you who doesn't know me, I'm Eliran. I'm a founder of a company named eSquare. I'm a Google developer expert for Angular web technologies and organizing the Angular TLV community and conference. I will mention that in a second. A word about my company. We're an Angular-oriented consulting firm that specialized in everything related to web frameworks, but more focused on the Angular ecosystem. We do staff augmentation, consulting, and trainings, and you can check out our website to learn more about that. I mentioned Angular TLV, so we have we're reviving with the entire things going around the Angular ecosystem. Lately, we also decided to revive our conference in Tel Aviv, so it's next month. If you're there or want to check the data, angular-tlv.com. What we're going to talk about today. So we're going to talk about what are signals, to touch on the primitives that signals bring with, why do we need signals in web frameworks, and we're going to build one. But not only that, 2 days ago, I think the Angular core team just announced that they're going to change the effect function significantly, so I couldn't ignore it, and I'm also going to touch it during my talk, and we're going to wrap it up all together. Now, I know that in the Angular ecosystem, everybody is really excited about the introduction of signals, but signals are not just a thing of Angular. We see signals around everywhere in JavaScript, in the JavaScript ecosystem, and I have to be honest, I thought that First Solid was the first one introducing signals, and then I learned that Vue also have proxies, and Quick also supports both proxies and signals, which rely on the same architecture, more or less. And you see that Emma was here today in the morning and spoke about the Angular momentum. So actually, I'm feeling like that's the JavaScript momentum, the JavaScript ecosystem that's growing and growing with so much amazing frameworks. And you see that most of them adopting the same concepts. And in the end, even though we have multiple web frameworks, we see that in the end, most of them sharing the same architecture, the same needs, and most of them needs a reactivity system I will touch it in a second, why they need it, okay? But before, quickly, what are signals? And if I try to define a signal, I will say it's just a value plus the change notification delivered synchronously, okay? But it's not only that. That's a simple thing. A signal is also a dependency graph that can tell you whenever a signal which depends on another signal, and this signal is get updated, then what's the entire tree, which exactly nodes needs to be updated. So we get not only the change notification, we also get the dependency graph. And this is more or less something exciting, and we will see why we need it in Angular in a second. So just to wrap up signals push-based synchronous reactivity system. Signals always have value, easy to read everywhere. Signals doesn't have side effects like unsubscribe, and it has automatically dynamic dependency tracking. Signals have 3 main primitives. The signal itself, the computed, which is whenever you derive from another signal, it gets updated, and the effect, which is just an operation that happens whenever your signal is updated. And we're asking ourselves why web frameworks need signals. You know, we are in an Angular conference, so I will take the Angular example. And let's imagine this as our tree DOM. And imagine that we have in one of the leaf, we trigger an event that needs to trigger change detection. So traditionally, in most web frameworks, this was going to happen. The entire DOM tree is going to re-render. In Angular, actually, it's not really re-rendering, because in Angular, we have just checking of the bindings that if the value changed yes or not, and then update it. Now, of course, on push makes it more efficient, but in the end, more or less, frameworks have the same need to check the entire, at least, route between the root and the leaf. Now, yeah, okay. Now, with that said, we understand that if we will have a reactivity system that's telling us that which node in this tree depends on what model, or in what's the models that are actually creating this DOM. So we can update a specific DOM without updating the entire tree. And this is the reason Angular chose signals as their solution to approach this reactivity upgrade. And it's also going to help us move to zoneless application. And now, talking about signals enough, let's see how easy it is to create a signal from scratch. So we'll open my IDE. I hope that the dark theme is all right. Should I replace it to white? Or that's fine? Fine? Amazing. And let's quickly create a new file and call it signal.ts. So signals mainly have two functions in them. Okay, so I will create. That's fine, people in the back? Cool. So let's quickly create signal function, which is, you're getting a value of type t. Let's declare t, of course. And you have two functions. The first one is read, where read just return the value, and write that white will take the new value and just set the value to new value. So far, easy. Let's return a tuple of read and write. And of course, this should be of type T. And of course, TypeScript can be, because we have two different functions, TypeScript can't automatically infer the type. So we need to tell the type. So this is a function that's getting nothing and return t. And we here have a function that gets value of type t and return void. We have a basic signal. Let's use it. So let's create our first. Let's create counter and set counter. Set counter. Yeah, with create signal. Now create signal. You see, by the way, you see that the Angular. I can import it from the Angular core primitives. Let's not use it. Let's use the one that we just created. Of type, the type will be number, and the initial value is going to be 0. Now, if I will set the counter to 1, but before, you know what, let's run something, let's add console log here with counter, and look in our application, we will see that nothing actually telling us that the counter has changed. We need actually to run this function once again. And this is not what we want. So in order to take our naive signal implementation into a real signal implementation, I'm going to introduce some new interface called node runner. Node runner is going to be the specific node of signal in the dependency graph. And now what I'm trying to achieve is to make sure I'm creating the dependency graph itself. Whenever a specific node is updated, I want to update its dependencies. So every node will have an execute function, which is going to be a function that returns void, and the list of dependencies. So we have dependencies. No, then sys. That's good. And this can be a set of any. Cool. Now, after we have this one, we can create a context. A context, it will be an array of the entire node runners. And I also need two helper functions. The first one going to be subscribe function. Subscribe with the node, which is going to be of type node runner, and also the subscriptions. Subscriptions, which is going to be a set of node runners. Now, whenever I want to subscribe, I just want to tie it between the specific node and the list of dependencies. So I'm taking the subscriptions and registering the specific node, and also go to the node dependencies and add the subscriptions to this one, making the coupling. Now, I mentioned I also need a cleanup function. Cleanup function that will take the node of type node runner, and here just iterate over const depth of node dependencies, and I just can delete them from the list. And whenever I deleted the entire list, I can just clean the node dependencies, clear the entire list. Now, we have these two helper functions. We can go back to our initial create signal function and enrich it a little bit. So let's start with creating the subscription, the list of subscription. I'm creating the list of subscription, called subscriptions. It's going to be a new set of node runners. And whenever I do, I'm calling the read function, I want to do the next thing. First of all, I want to take the last context node. So I'm reaching to the node where it sits in the context. And as I know, it's the last one, context left -1. If I have a node, I want to run the subscribe function between the node and the list of subscriptions. Whenever I do, whenever I run the run function, the write function, I just want to iterate over the list of subscriptions, and run the execute function. Now I have a real signal. And with that, I can create a real effect. So let's quickly create our effect function. Export function effect. And our effect, we know that the effect function will get a function, that it's a function that we don't really know what it's going to return, but we know that we need three things. First of all, we need the execute function. So let's create the execute function. It will be a function that we will define in a second. We need to create a node runner. So we're creating a node of type node runner, and creating the execute first, then the list of dependencies. And here the dependencies can be just a new set. And in the end, we want to call the execute function. Now, the execute function going to help us enter what we did into the context. So first of all, we run the cleanup function over the node. Then we're pushing into the context the specific node. And then we can just trigger the function itself, where finally, we want to remove it from the context. That's it. Now let's go to our code once again, and then instead of using console long plenty of time, let's remove everything here. Or you know what, we can keep it. Let's just remove the console logs. And instead of that, we can add an effect function, which we import from our file and not from Angular core, and run console log over this counter. Not this. We're not in a class. And we get actually the subscriptions every time the counters change. It's not only that. We can put many subscriptions on it. You know what? Let's quickly create another example with names. So let's say I have a first name and select first name, set first name. Let's change it to be a string. And this will be Eliran. And this will be last name with set last name. And this is going to be a string Eliassy. This is my name. And let's say I have an effect function that logging the name is, and here I'm setting a few dependencies, not just one. So let's take first name and last name. And if I will change the first name to Martina. Martina is it? To Martina. Martina, welcome to the Eliassy family. So I see that it changed once, but now if I will set the last name, even though I haven't said anything about who's the dependencies, it makes it automatically. So Martina Cross, I see that actually it gets updated every time the effect function runs, every time one of the dependencies is just changing. And this is the magic, more or less, behind signals. And I have enough time to go over what's changed lately in Angular. So a few days ago, I think 2 days ago, the Angular core team just announced that they're going to change the effect function significantly. And because of that, they more or less going to keep it in developers preview in version 19, even though it can change in a minor version. So we don't have to wait 6 months. And you see many blogs and videos. I saw Ben Lesh saying, don't use effects, get away from effects. And I actually checked the docs, the Angular docs, about the entire signal guides. And you will see this in the docs. Signals and effects are powerful stuff, right? And usually what's happened, and you've been in a conference, you see something amazing like effects, and you're coming back to your day-to-day job and say, hey, let's change everything to signals and effects. And why not? But you didn't check up the docs. And the docs actually telling you that it's a little bit too dangerous to use effects everywhere. And there is a specific scenario where Angular wants you not to use effects, and they're going to enforce it while they're going to remove the allow signal rights that I'm going to show in a second. The main reason is because the schedulers of signals is not the same as the Angular change detection schedulers. What can happen to you is you're going to update one of your dependencies, and in the end, you will find out that your effect runs way after the time that the DOM updated. Okay, so you can have what we called in the ecosystem, we called a glitch, and mainly you will find that effect is not the primitive that you're looking for. So this is the blog post, by the way. I encourage you to have a look in the last updates on to the effect function. And to demonstrate the problem and the solution, I will quickly go to create a new component. So let's quickly create a component, and let's call it a select component, OK? And inline template. Amazing. So we have a select component. I will increase the font so everybody can see. And let's imagine that we have options, a list of options that we're getting from outside as a signal. So the type going to be, it's going to be an input of string array. And let's initiate it to be with just an empty array. Now, you don't want just the options. You want to have the selected options, the selected option. Selected option. And it's also going to be a signal of type string. And in the beginning, when nobody chooses a specific option, you want to have it empty, an empty string. Now, the template is going to look something like that. So I have an unordered list, and I'm iterating option of options, and have a list item that on click going to run select with the option. And here, let's just print the option. Let's quickly implement the select. Select will get an option of type string, and take the selected option, set the value to the option. Now, options can change from the outside, right? It's a DOM component, so options can change from outside. And we actually want to have the ability to reset the selected option. So the first thing come in mind is to create a constructor, create an effect function. By the way, let's make sure that we're using the right effect. Right now, we're going to use the Angular effect. And we subscribe to the option list. Whenever it changed, I can just set the selected option to be an empty string. And the problem with it is, we just mentioned, we're trying to mix two reactive systems, trying to sync two reactive systems into one. And this is not the way of doing that. Now, there is a solution for that, and it's changing in paradigm and even changing the way we think about effects and compute it. So the way the Angular team and Alex Rickenbauer showed it a few days ago, want us to implement this specific situation is, instead of having a selected option, we can just get rid of it, okay? Instead of that, we're going to create a state. Whenever we need to sync, by the way, first of all, this is not going to work out. Let's get this back. This is going to throw an error, okay? Whenever we set a signal inside an effect, right now, and this is going to change in the next version, we have allow signal rights true, okay? We have to do that, otherwise we're going to have a runtime error. Now, the way the Angular team wants us to solve it is, instead of holding a select option, we can create something that's called state. And instead of using effect function, we're going to use the computed function. Now, the computed function, you know what? Let's leave the type for a second. I can create a function that will straight immediately return an object. And the object will set the state of the component. So we have the options, which is going to be the options that is part of the component. But we're going also to have a selected options, which instead of being just a part of the computed, it's going to be another signal of string inside the component. And now every time options changed, selected option will be reset. The moment we say we did it, we can definitely get rid of the constructor and the effect we created. We can definitely here, the way we need to update it is just call the state. We don't have a selector option. What happened? It took a second. And here, we're not showing the selected option, but let's say we did. So we have a selected option is with state dot selected option. Okay, so this is the new stuff coming to Angular and the way Angular wants you to think about that. There is also going to be a change in the way that effects going to be implemented in terms of timing. So effect is going to run as part of the change detection mechanism and the component change detection to be exact. So you also be aware of that. Again, really encourage you to go to read the blog that Alex just posted 2 days ago. So it's the latest news coming to everything related to signals. And if you want to try to take a takeaway from the last example is effects are the way to sync between the reactive system and the non-reactive world. Don't try to take two reactive systems and use effect between them. This can cause you huge bugs and problem in your runtime application. A word about the future, and if we look about signals in general in the ecosystem of not just Angular, in JavaScript, there is a TC39 official JavaScript proposal to make signals part of the language. We see that the adoption of web frameworks is not just an hype. It's something that we probably going to have, and it's really needed, even though it's still in early stages, but there's already something like that. And I know that Angular has their own implementation, but just imagine that one day the entire JavaScript ecosystem going to share the same primitives and a way of sharing signals between. Yeah, that's it. That's all I have for you today. Thank you very much for having me. This is my contact and handle. You can, of course, reach out to me. I'm going to be outside if you want to talk about what we just said. And thank you very much.